Hello my dear students, welcome to computer science class. In our previous video classes, we have seen the jump statements of exit and continue. Today, we are going to discuss about the goto function, which is another jump statement. Now before I proceed this goto function, let us see in what situations we can use the exit and continue function. We shall have a quick glance. As we know that exit is a function that belongs to an standard library file, that is stdlib.h. std stands for standard, lib stands for the library. Therefore, the exit is a function that belongs to standard library.h header file. Okay. And then when to use this exit function? Suppose whenever we want to immediate termination of the program. Okay, if your program situation demands, like whenever any errors or any unexpected results it is leading to, in that case when we want immediate termination of the program, then we can go for the exit function. And we also known as exit function returns the integer value to the operating system, that is either 0 or 1. Exit of 0 means what? The program is successfully executed. If I am returning apart from 0 any other value, that is exit of 1 if I am returning, that indicates an abrupt or unsuccessful program execution of the program to the operating system. It will send the value, isn't it? Now next we have also discussed about the continue statement. Continue statement actually, suppose if I want to skip one of the iteration, if I want to skip the current iteration and I want my next iteration to begin, okay, new iteration to begin, half of the way, might be some 4 or 5 iterations you have already completed, maybe 6th or 7th iteration you want to skip and then proceed with the 8th one. In that case you can go for the continue statement, wherein this continue statement causes and jump to the start of the new iteration in between itself. So for that reason we can go for the continue function. Now let us move on to the last jump, that is last jump statement, that is goto. Now why this is goto is being used? So this goto, it makes an jump to one point to the another point in the program. This goto function makes an jump from one point to the another point. Now as the terminology is go to, in the sense, suppose if you are at the step 2, okay, if I write it as in step 2, if I write it as go to step 6, then there will be a jump from go to step 2, from second step to the 6th step. So in between the 3rd step, 4th and 5th, everything will be skipped and the control jumps to the 6th step. That is what this goto statements makes and control to jump from one point to the another. So therefore we can say it causes an unconditional jump, or you can, other words we can also refer it as it transfers the control from one statement to the another statement in the programming by ignoring if any of the looping statements are being included. Suppose in a program any looping statements, if it has been included, it will neglect that. It will, neglecting, it causes and jump from which step we had mentioned to the another. Now how to identify this goto? So therefore we have a label which is made up of an valid identifier which has been followed by the colon. Let me show you here. Okay, as I have explained here, goto statements makes and jump ignoring any kind of nesting limitations. Okay, now let me show you. See here, we have a valid identifier wherein it should be followed by the colon. Now let me see the general syntax to get an idea. See here, in your program execution there is a statement 1, statement 2. When you come to the statement 3rd, okay, there is a label called as go to label name. Label name in the sense what? Now maybe this is, here I will be writing step 1, step 2, this is step 3, 4, 5 and this is step 5, okay. Now at this point, this is step 6 actually. Now here go to step 6 I have written. Now this step 6 will become a label name, okay. and here it will be written as step 6. Now this is actually the label name followed by the colon. So this is indicates when the control comes at the third step, it encounters go to step 6. So once the controller encounters such statement, it will skip the in between statement and directly control jumps to the matching the label name. This label name and this label name, there should be a matching. So this here is step 6. So here is also step 6. Then the control automatically makes and jump to the step 6, and then the sequence of next instructions will be executed. It will skip the in between part. I hope children you are able to understand. Now let me show a program for you so that you can clearly understand how the go to statement works. So just you should remember, go to is one of the jumping statement where it causes an jump from one point to the another point. So look at here, this is a program to print the numbers from 10 to 1 using the go to statements. So these are the header files what I am using here, and then followed by the main function. Here we are taking a variable known as n of type integer where it's holding a value as 10. Now see here, this is a loop. Okay, this is one of the label. Okay, this is a label. Loop colon. We know that in case of go to, a label is made up of a valid identifier. This is a valid identifier. Okay, it's a go to label. It's a valid identifier and it is always followed by a colon. So at this loop, what I have written, I am printing the value of n. I am setting the width. Okay, before I am printing, I am setting the width of 5 spaces and then followed by n value is been printed. After this, what happens? N gets decremented. When n gets incremented, if it is greater than 0, we have encountered what? Go to statement. Where it should go back? It should go to, either it might be further or it might be behind also. In my previous general syntax, I have shown that we are moving from, we will be at the step 3 and we are moving to step 6. So it might be vice versa also. Now here what we are doing? We are in some other step and we are moving backwards. So go to followed by the label name. Which step? This is the label name. So it's saying go to loop. Now here is the label name. Now when the controller encounters this step, the controller will understand that, compiler will understand go to is a jumping statement and it is saying to go to the label where it matches as loop. So it will again search where there is a label match. Here is a loop? No. Here when it comes, the match is found, and then what happened? Again n gets printed. Again n value gets decremented. Okay, and again n is greater than 0. Initially the value of n will be 10. So first time 10 is printed, 9 gets decremented. Okay, whether 9 is greater than 0, yes, condition is true. Again go to loop. So control comes here. Okay, again 9 is printed, decremented, 8 is greater than 0, yes, again go to loop. Like this, the go to statement will make an absolute or unconditional jump from one statement to the another statement by skipping the statements in between. I hope children you are able to understand. So here I haven't used any of the looping statement. I didn't use the while, I didn't use the do while, neither I have used the for loop. But still with the help of go to statement, jumping statement, I can have the looping system here. And then what happens finally, once 0 is greater, once the value of n becomes a 0, we are checking the condition whether 0 is greater than 0, the condition fails, because once the condition fails, okay, it will not execute this one. This is a true part of this condition. They have written in the same line. Okay, the true part of this if condition is go to loop. So because condition is failing, this particular statement will be skipped and the control comes to the next statement where it is written as end of loop. I hope children you are able to understand. And therefore you can see the output as 10, 9, 8, 7, 6, 5, 4, 3, 1 and end of the loop. Let us understand the tracing of this program. The same code I have written here, children. You can see the code is the same here. At the first iteration n value is 10. Okay, 10 gets printed first. at the loop, okay, 10 gets printed and then the value of n gets decremented. Therefore, the value of n becomes what? 9. So, if 9 is greater than 0, the condition is true. What is the true part of this if statement? That is the go to label. So, when it comes here, go to, where it should go? It should go to the loop. When it says that go to the loop, control will go in search of where the label name matches as loop. Here the label name matches. So, therefore, the control comes to again back to this same statement where again the n value right now, because we have already decremented, the n value would become 9. So, 9 is printed, again value gets decremented, again 8 is greater than 0. Yes, the condition is true. Again it encounters go to loop. Again loop, it's okay, loop, control goes to the loop, the same label name. Then again 8 is printed, 8 gets decremented by 1. So, 7 is greater than 0. Yes, the condition is true. If so, go to back again to the loop. So, similarly, the same for the 4th iteration, 5th iteration, 6th, okay, 7th and 8th. When it comes to the 8th iteration, okay, here the explanation remains the same, children. You can trace the program with a different number. See, when it comes to the 8th iteration, what happens? The value, okay, the value of, n would become 2. It would be 2. So, therefore, loop 2 is been printed and then 2 gets decremented. So, here I am having the value as 1. Whether 1 is greater than 0, yes, the condition is true. What is the true part of it? That is go to. When it comes to the 9th iteration, here the n value will be, previously it was being decremented. So, the n value will be 1. So, after that the value of n will be, yes, the value of 1 would get decremented. So, here we are first printing the 0. We are printing the value as 0 and then I am checking whether 0 is greater than 0, the condition is failed. Once the condition is failed, we know that the true part of this if statement is go to loop. Because the condition is failed, the true part will never get executed. Instead, the control goes to the next statement. That is, it goes to the next statement after this true part of the if statement. Therefore, end of the loop will be printed. I hope, children, you are able to understand. So, let me execute this program and show you so that clearly you can get to know how the go to statement works. Okay, here is a program, go to, see, the program is same as what I have shown here. Okay, I will just compile the code, I got 0 errors, and when I run the code, see, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and then end of the loop I am getting, isn't it? Okay. Now with a different value we will see. I didn't give any input because we have already set the value of this particular variable, that is n, that is 10 we have done. Let me give another different number and change, we'll see whether how it works. So this time I'll set it with the 15, okay, and then I'll save this code and then I'll just run. See here, go to I have taken. So every time the n value is printed, decremented, condition is checked on satisfying, again go to loop. Now this I can call it as a label followed by the colon. Okay, I'll just run. See, 15, 14, 13, okay, 10, 9, 3, 2, 1 and then here it is actually end of the loop. It is there. Here you can see end of the loop. I hope, children, you are able to understand. Okay. Now, as per this, it completes the complete chapter. Okay. But, so behind the chapter, there are few questions, children, which are important. Okay. So, let me discuss those code. Like for example, correct the following code you have, or consider the following program segment and find out the output. Okay. Then some other program segments are there where you need to check for the input and write the output. So those programming codes we shall understand. Okay. Yes. This is a question number 12 in your textbook. Okay. So what is the question is, correct the following segment. Correct the following segment. So they have given this particular program segment wherein you need to find out where is the mistake is. Now look at the first one, children. Now this one, if x is equals to 1 it is. Is it equality operator or is it an assignment operator? It's an actually assignment operator. If it is an assignment operator, how can I check for the equality? Then it would not become a condition at all. This statement indicates that the value 1 is being stored in a variable known as x. Then it doesn't make any of the condition. So therefore, what should be the correction code here? How I should make the changes here? I should have written if x double equals to 1 on satisfying this condition, I am going to print the value of k to be as 100. Else, I am going to print the value of k to be as 10. Maybe I have given the x value as 25. If so, I should have written the code as if x double is equal to 1, I should check. In that case, I am checking what? If 25 double equals to 1. The condition is false. Because the condition is false, this k value will not executed. In fact, the control comes to the else part where it displays the k is equal to as 10 it would display. That means k would be holding the value as 10, not as 100. Now what if I enter the value of x to be as 1? Whether 1 is equals to 1, the condition is true. Therefore, on satisfying this condition, the true part of this particular if statement is this value. Therefore, k will be the variable that would hold the value as 100. I hope children you are able to understand. The mistake is here. We are using an assignment operator where we should have used as equality operator. Equality symbol we should have used. If x double equals to 1. If so, x we have to ask the user to enter. So based upon whatever the user enters the value, based upon that value, if it is equals to 1, then k would hold the value as 100, else the k would hold the value as 10. I hope you are able to understand. Moving on to the next programming segment here. So therefore, correction would be if x double equals to 1. So I am telling for your understanding double equals to, but actually it is an equality operator. Okay. Moving to the next programming segment here. See, consider the following program segment and find out the output. Now, here is the value of x to be as 10 and y value is what? 5. Now, they are checking the condition. If x is greater than y, on satisfying this condition, w would hold the value as 15. This is simple if statement. Therefore, it doesn't have any false part. Only the true part it will be having. On satisfying this condition, the very next statement after this if condition, which one is? It is same. This one. See, I hope you remember in previous classes also I have explained. So, this is a valid statement. This is actually involving two instructions. If x greater than y is one instruction and w is equal to 15 is another instruction. You may say, there is no any semicolon to indicate that they are two different. No. Why? Because if condition, that is looping statements, cannot have a semicolon. They don't end with the semicolon. Understood? If you give here semicolon, if x is greater than y, then semicolon means. So here compiler will never take this w is equal to 15 as a true part of this if condition. It indicates that we don't have any statement that is related to this particular if. Therefore, it will never execute the correct value there. So, to avoid that, okay, we have not given any kind of we have just written this same two different statements only, single statement. So, if x is greater than y, the true part on satisfying this, w would hold 15, else the w would hold 25. Now, according to this, now let us consider x to be as 10, y to be as 5. Whether 10 is greater than y, the condition is true. Therefore, what would be the answer of w? Whether 15 or 25? Definitely w would hold the answer as 15. Now let me execute this program and show you. Let me come back to the program here. I just open the code. See, I've just converted, that is a simple program segment. I've just written this in a program form. Okay, let me execute this one. Just go for compile, get 0 errors, and just run the code. Now we know that x value is 10, y value is 5. Okay, whether 10 is greater than 5. Yes, the condition is true. On satisfying this condition, what the w should hold? 15. If x was not holding the value as 10, some other, okay, like 100 if it is greater than 5. So let me take it y to be as 500. Whether 100 is greater than 500, the condition would fall. So therefore that time w would contain what? 25. Okay, let me execute here. Because the n is equal to 10, the x is equal to 10 we have, the answer of w it is 25 because it is satisfying the given condition. I hope children you are able to understand. Okay. Now let us move on to the next question. That is question number 14. Okay. Question number 14. Look at the question here, children. What will be the output of the following code fragment here? Previously, they have asked the user to enter the number, and whatever the number the user is entering, it is being stored in a variable known as a. Now, they are checking the condition if a is equals to 50. Now, this is what is a equality symbol. It is asking like whether if entered value is it equals to 50. On satisfying this condition, we are printing as 50. Else, on not satisfying this condition, I am going to print it as not 50. Now here, they have only given the input. First give the input 70 and check, and second time you give the input 50 and check what is the output. Now let us say, assume the value of a to be as 100. Whether 100 is equal to 50, the condition is false, and therefore if it is false in case of if else statement is a one which will never execute the both true or false condition. Only one condition it would execute. So therefore what happens here? Let us execute. So because if a value, if we are assuming as 100 is equal to 50, the condition is fails. Therefore control comes to the false part, wherein we are able to print the answer as not 50. I hope you are able to understand. Now let me show the execution of this program. Coming to the 14th program, children, here. I'll just open the 14th program. Okay, just open this and then compile. 0 errors. See, the code is same. Let me run the code. See, enter the value of a, they are saying. Now let me enter the value as 13. It might be input, might be anything. Okay, just the program should work for all the numbers. Enter the value of a, that is I have entered as 13. So therefore it is printing me the output as not 50. Okay, it's printing me as not 50. Now what if I give the 50 only? What the answer should come? If I am giving the input as 50 directly, if I am giving this way, it's printing me 50. I hope children you are able to understand. In question only they have asked you to give the input as a 70, then what answer I should get? Just check it and see. 70. See, not 50. I hope children you are able to understand. Now here, next program we shall see. This is a program wherein to find whether the entered year is a centennial year, is a leap year or not. to find out whether the entered centennial year is leap year or not. What do you mean by centennial year? Centennial year in the sense after every 100 years. What year we are getting? I is said to be as a centennial year. That means a period of 100 years is said to be as a one centennial year. For example, 2000. For example, 1800, 1900, 2000. All these comes under the centennial years. We know that what is the rule to find out the simple leap year? That means the number should be completely divisible by 4 and the same number shouldn't be divisible by 100. Am I right? But if any the given number, if it is being divisible, not divisible by 100, but if it is divisible by 400, then what I can refer it as a leap year. Okay, otherwise I can refer it as an not a leap year. I hope you are able to recall. Now let us see the programming segment, what it is being given here. According to this, what should be the output we should predict. That's it. Now this is a given code, okay, wherein they have taken a variable known as year of data type, that is integer, and they are reading the year. What they are saying is, if the given year, if it is completely divisible by 100, when you do the modulus operation, it should result in 0, and the same year also should be completely divisible by 400, where the remainder I should get 0. Such years can be said as leap, else we can say refer them as a not a century years. Okay, not a century year. I hope you are able to understand. According to this program segment, okay, what they are saying, if year is completely, this is modulus operation where we are seeing the remainder. If the given year is completely divisible by 100, plus on satisfying this if condition, what is the true part of this if condition? That is very next statement. This is a true part of this particular condition. So on satisfying this condition also, okay, I am printing as leap year. On not satisfying, then I am printing that is not century year. Now let me execute this program and show you for you. One second. That is going to file, open. Let me give the file name here. Once again, children, let me open that file. Yes, here the program is. See, this is the program what I have written. The same program it is. Okay. Let me give the input here. Let me first compile. 0 errors. We run the code. Now it's asking me to enter the year. Now I'll see. I'll give the 2000. I'll give. Isn't it? It's a century year. Now let me see. As per the given code, 2000 when you divide and see remainder, modulus operation if you do and see, okay, I am getting the remainder as 0. Okay, I am getting the 0. 100 divided by 2000, 2000 divided by 100 you do and see. Firstly, we get what? 100 2s are 200 we are getting. 100 2s are 200 and that 0. That means that 0 is remaining, so you are adding. So 100 into 20. 100 into 20 when you do, I am getting what? The remainder as completely 0. Therefore, 2000 is been considered as a leap. Understood? This I am getting the program. I didn't write the complete. This is the only the program segment what they have given, and they are asking you to just predict the output. As per the given code, you should be able to predict what output you are getting. As per the given code, if I am giving the input as 2000, it will print me as leap. Understood? Therefore, I didn't mention any extra as leap year, not a it's a centennial year. I didn't mention, because look at the program code what it is given. What is there in the cout statement? That's only leap. Okay, this is a program code. Based on this, we need to predict the output. In the examination, they may just ask you, give the program code and ask you to find out the output. You cannot, execute like this and check and say, no, you should, by looking at this program code, you can make out, okay, what should be the output. Similarly, let me give another input. Now this time I'll give an input as 1900. Okay, I'll give it as 1900. I'll give and just press enter. See, it's saying that not a century year. It may divide by 1900, but it cannot be divided by 400 as per our program segment. Therefore, we consider that it's not a century year. See, whenever you enter here the year 1900, it will be stored in this particular variable. Whether 1900 mod 100, is it resulting in 0? Yes, fine. Again, on satisfying this condition, control comes here. Whether 1900 mod 400, is it equals to 0? The condition is fail. Because this condition fails, what is the false part of this if statement? Where it has been present? It is present in the else part. Therefore, this cout statement you can see on the output screen as not century year. I hope children you are able to understand. So some more programming examples we shall discuss in our next video classes. Thank you students. Take care of yourself.